It's hard to talk about all of this in a short amount of time, so I'm happy to answer questions and talk to people later as well. Paul's introduced this feature, but I will just go ahead and dive in. I won't dwell on this slide because I had a feeling this would come up a lot at this conference. The reason we consider this potentially cryovolcanic is that it does look like there's been creation of new surface, and it looks like material has been placed onto the surface to create that new surface. We don't know how much melt was involved. And again, as several people have mentioned, if it was purely solid state, maybe you would call that extrusive diapirism. But like a lot of the features that we're looking at today, there's not necessarily a perfect analog from the terrestrial literature, either for volcanism or diapirism. So this is really, I think, a unique feature. But we're looking for collaborations, and anyone who wants to think about this, we need lots of creative ideas. So this is the main feature that I'm going to talk about. It's informally called Wright Mons. And there are some other terrains down this way and actually probably spreading out this way as well. So there's a lot of potential material involved here. We've done some preliminary mapping. I should mention also that the Wright Mons is down here at the tip of Pluto's heart. And I think I'll just dive into looking at some of these terrains more closely. And Paul already mentioned Picard Mons, so again, I won't dwell on it, but just a quick note that the reason we were able to see past the terminator here was actually because of hazes reflected out of Pluto's atmosphere. So this is a haze light image, and Paul was able to extract some stereotopography out of that, although of course the quality of the data is not as high as for the sunlit region. So there's potential for more of these features to exist. And Picard Mons is in fact even larger than Wright Mons, but I'm going to focus on Wright because we have the best data for that. Oh, I got to start this. Okay, to introduce some of the interesting terrains here. As I mentioned, this is the main mound. It has a very large central depression. I actually usually avoid calling it a caldera. And I have some stretches of the interior I'll show later. There's this funky hummocky terrain. And I also want to remind people that the light is kind of coming from this direction, and so it's very close to the terminator. So some of these things, some of the more linear type things are exaggerated by the lighting. Let me run that one more time. And then there's even a smaller scale kind of lumpy texture superimposed on these hummocks. These hummocks are about 8 to 10 kilometers across. The entire feature is about 150 kilometers across. The central depression takes up almost 1/3 of the entire feature. It's about 45, something like that, kilometers across. Yeah. Yes. I can't remember exactly what this one is, but it's only 4 kilometers tall and 150 kilometers across. So this is probably maybe 10 times, something close to that, 5, 10. Gives you an idea. I do have some profiles where I have taken out vertical exaggeration in a couple of slides. Just the top-down view now to point out a few other features. There's a number of other large depressions in the area, and as Emily introduced earlier, a lot of these things we don't think are craters, so we're trying to explain them other ways. There's not a lot of evidence for individual flow fronts, which you've also heard about on other places. But the difference here is that these are very large topography structures. They're not smooth, pretty much almost in any way. There is one potential individual flow event. That's this little thingy right here. And I'll probably show that again in a couple slides. There is evidence for potentially having multiple emplacements of this material, though. We're speculating that some of this stuff up here and some of this stuff over here, which you can see has somewhat of a similar hummocky nature to the flanks of Wright Mons, but it's much more cracked up. So we're speculating that maybe these are older versions of these same kinds of terrains. I think that's mostly what I point out here. You can see there's not very many potential impact craters on this structure, which is why we think it's relatively young. There's a stretch now of the central depression, and in general, it's fairly hummocky like the exterior. maybe not exactly the same, but it certainly doesn't have a lot of the classic either faults or what's the word I'm looking for? Anyways, doesn't show the classic collapse structures that we often see in a caldera-like structure. So we don't even know for sure the material is necessarily coming from somewhere in the middle to the outside, but just a couple of hints that might be happening, or at least that this is the youngest area or the most recent activity, is because we see some of these older ones that appear to be farther from this feature. Obviously, it's a very large topographic structure, and it has very few craters on it. And it's somewhat annular, somewhat concentric around this central depression, although not perfectly. Okay, so if you pretend you're flooding the feature like this, you can get an estimate of the amount of volume of material that's just in this main topographic structure itself. As I mentioned, there's a bunch of other terrains around here that could be quite extensive. These actually I didn't mention, but these are more like the chaotic terrains that we see elsewhere on Pluto. They're called mountain blocks in Pluto, but they're very similar in terms of looking like broken up pieces of the crust. So they may actually be completely unrelated to this. But you get a volume of about 7 times 10 to the 4th cubic kilometers, which I'm sure you all can imagine exactly how much material that is. But for comparison, I tried to find some estimates for Mauna Loa, and I kind of found a range, but in general, they're fairly similar to just the amount of material that's in Wright Mons. Having said that, the shape is very different. I only had the topography, not the bathymetry, so it continues down here, Mauna Loa. But in general, Wright Mons, the entire middle portion of it is not there. And you can see that the central depression goes down to the level of the surrounding terrain, or even possibly lower. So it's very deep and very broad. And here's your unexaggerated profiles for reference. So it does have somewhat shallow flanks, but that may be one of the few things that it shares with your classic shield volcano. Okay, quickly summarizing, we seem to have a lot of material involved. This material was potentially able to flow at some point in the past, but it also can maintain topography now on the surface of Pluto. We believe it's probably relatively young. And we see all these really interesting textures all over the feature. So this begs the question of, what do we have here? Again, as many people have brought up today, what's the potential compositions involved? What could any potential heat sources be that would be operating later in Pluto's history in order to get resurfacing later in its history? And I just put a bunch of question marks here because this brings up a lot of fun ideas to play with. It's difficult to talk about Pluto's composition quickly, but I'm going to try. And again, happy to talk about this more later. So Pluto has, in addition to water ice, it has these 3 main volatile ices that can sublimate and redeposit on Pluto's surface in different diurnal or seasonal cycles. And this is from the LISA instrument on New Horizons. You can see carbon monoxide here in Sputnik Planitia, which is equally fascinating, but not for this talk. There's plenty of nitrogen ice, and then methane pretty much plates out everywhere that's not dark. And there's a few other situations in which methane doesn't seem to have deposit on the surface. But in general, methane mostly plates out everywhere. So that covers up a lot of the signature of what's in the subsurface, especially in the Wright Mons area down there. For interior structure of Pluto, this is from Bill's 2017 paper. And we have about 2/3 rock, 1/3 water ice, plus all those other fun things up there. And there's potential for a liquid water ocean to remain in the interior of Pluto as well, although we generally assume that it's under a nice thick coating of ice. So in terms of what could be making up the bulk of the material in Wright Mons, we definitely see lots of evidence of flow of N2 ice on Pluto. We have beautiful glaciers. On Pluto, there's a lot of very strange things, but the glaciers look like glaciers, so that's nice. But it won't maintain topography at Pluto's surface temperatures. So we generally assume there's water ice probably there, mixed with other things that have been discussed today. Methane is one other possibility, because there is a fair amount of methane. In addition to surface deposits, there is one region on Pluto, it's called the bladed terrain, that has very, very strong methane signature. And it's been speculated that these could actually be a larger deposit of methane. But you get these very distinctive sublimation features because methane can sublimate at Pluto's temperatures, and does. And you could maybe argue some of these textures are somewhat similar to this, but you certainly don't see this strong bladed terrain signature here. So in general, it's quite possible that a lot of this is water ice mixed with other things. And I'm getting short on time, so I'm going to go ahead and keep going. But remember, the surface temperatures are very low on Pluto. Tidal heating should have ended very early in Pluto's history, according to the models. Radiogenic heating, even in the past, has always been relatively low, just based on the rock fraction of Pluto. And even though we do predict that you could have potentially a subsurface ocean even into the present, we generally assume that it's quite far down, as I mentioned. So it's not actually obvious of course that's why we didn't predict that we would see something like this. It's not obvious what recent heat source could be mobilizing material near the surface. So we have a bunch of fun ideas that people on the team are working on, and again, we're open to collaborations on this, and you'll hear some more from other talks later today. My preferred hypothesis is viscous flow. I kind of see the flanks as like giant pahoehoe. So yeah, trying to get this kind of quasi-regular lumpy structure is a lot of what I'm thinking about. Of course, people like to talk about pressurized water eruptions for bodies that may have subsurface oceans even into the present. Could you have the nitrogen ice being the mobile ice and carrying other things? Although, again, it's not that. You still have to get the nitrogen ice uphill in order to do that. And again, also looking at just other ways to get the other constituents here possibly into this process. But there's not a lot of evidence here of necessarily any kind of ballistic emplacement. And again, there's not a lot of evidence of low viscosity flows. This is my favorite. I already mentioned that. To be continued. People are working on these. So just some, in the last minute, just various things that we're going to be looking at. And I'm really excited to be here so I can get ideas from you guys and learn about all the work people are doing on other bodies. But we don't have a lot of great possible analogs for Wright Mons. But one potential one, and I'll put Earth here for fun because it's different scale, but I like looking at it, is the funicular terrain, which is the terrain between the tiger stripes on the south pole of Enceladus. And here's some nice views put together by Paul, I believe. And you can see kind of a little bit of comparison here between the kind of regularly shaped lumps and even this smaller scale texture, which on Enceladus is boulders, although it's just at the limit of our resolution here on Pluto, so we're not really sure if that's ridges or boulders or what that smaller scale texture is. So I will end there. Thank you. I see.
Okay, do we have questions?
Oh.
I have no idea about the fine texture because we don't have pictures at this resolution. I don't know about the aspect ratio, but in terms of an analog for the deep, deep, deep pit that may go deeper than the surrounding terrain next to a big mountain, there's Sotra facula on Titan. And so that's maybe something to consider.
Yeah, thanks for bringing it up. Yeah, the stuff on Titan, at least from what I've seen in the topography, even though there's the deep pit and the mountain for like Mount Doom, they're pretty different in total overall morphology. So yeah, and scale actually as well.
The bladed terrain, I thought, like you said, was a sublimative feature. Is the illumination similar over these hummocks?
Actually, they are
now or in the past.
Yes, so they were both. Well, the imaging they were both near the terminator when they were imaged. So in terms of the lighting of the images, they're very similar. Slightly different angles, but similar incidents. So yes, they should all be exposed similarly, at least at this era in Pluto's history. They both come in and out. They both go into the night side and back out, for example.
So in the context of a viscous flow that you said you favored, how do you form the central depression?
I have no idea how to form the central depression. So yeah, that's why I was mentioned you don't see wall terracing or, I mean, maybe you could interpret some of that as terracing, but it pretty much looks kind of lumpy like the outside. So it's not clear if that's from collapse or not. It may be that you don't actually form, a very tall middle structure and then collapse it out. You could be forming the thing more as an annular thing to begin with. Could be, yeah. That's unfortunately, there's just not a lot of clear morphological indicators of the central depression, except that it doesn't look like a classic collapse necessarily.
Okay, do we have time for one more? While we
There's no
transition to the
obvious
next
hole,
talk?
for example, or yeah.
Cool talk. Do you know what loading multiple kilometers of ice would do to the state of stress around?